In this video I'm going to show you how to do Edexcel A-Level Maths from June 2023, Paper 1, Question 10. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition. I live in Buckinghamshire, England, and I can also do online. Please like and subscribe. The circle C has equation x squared plus y squared plus 6kx minus 2ky plus 7 equals 0, where k is a constant. Find, in terms of k, the coordinate of the centre of C and the radius of C. Okay, so the first thing you can do is, in order to find the circle and radius, you would want to rearrange the equation so it will be of the form of x minus the x centre squared plus y minus the y centre squared is equal to the radius squared. So we need to do the process called completing the square here. So what I'll do is I'll first of all write the terms in a slightly different order. So it will be x squared and then plus 6kx, and then plus y squared minus 2ky plus 7 equals 0. And then what we'll do is we'll complete the square here. So if we halve this 6k and write it as x plus 3k squared, that will give us x squared plus 6kx plus another 9k squared, so minus 9k squared. Do the same thing here, halving the minus 2ky. So it will be plus y minus k squared, yeah, and then that would give us y squared minus 2ky plus another k squared, so we need to take off another k squared, plus 7 equals 0. And now if we rearrange that slightly, we can write that as x plus 3k squared plus y minus k squared is equal to 10k squared minus 7. So now we can just read off the centre and radius. So the centre is minus 3k and k, just flipping the signs for these first two parts. And the radius will be the square root of the right-hand side, so the square root of 10k squared minus 7. I haven't got enough space on this page to do the second part of the question, so I've got a second copy of the question here, and we'll continue from there. The line with equation y equals 2x minus 1 intersects the C at two distinct points. Find the range of possible values for k. Okay, so at the moment the problem here is we've got an equation with y and x in it. We've got another equation y and x in it. So what we can do is we can transform this first equation into just an equation in x by substituting 2x minus 1 wherever there's a y in the original equation. So it'll be x squared plus 2x minus 1 squared plus 6kx minus 2k times 2x minus 1 plus 7 equals 0. Okay, let's expand this out. So we're going to get x squared plus 4x squared minus 4x plus 1 when we expand that out, plus 6kx. We're going to get minus 4kx, and then minus 2k times minus 1 is plus 2k, and then plus 7 equals 0. So we can now tidy that up. Okay, so with the x terms, we've got 5x squared. We've got 6kx minus 4kx, which is 2kx. And then we've also got a minus 4x here. So we've got plus 2k minus 4 times x here. And then as our last coefficient, we've got a 2k and plus 7 plus 1. So that will be plus 2k plus 8 equals 0. And you can see this is a quadratic equation in x, where the coefficients are 5, 2k minus 4, and 2k plus 8. So the coefficients using the normal letters for quadratics, a is 5, b is 2k minus 4, and c is 2k plus 8. Now what we know is we want to find a quadratic equation where there are two solutions, two distinct points. So that means the discriminant, b squared minus 4ac, has to be greater than 0. So b squared minus 4ac is greater than 0, and we can just substitute that into this inequality. So it will be 2k minus 4 squared minus 4 times a times c, which is 2k plus 8, has to be greater than 0. Now what we can do is expand this out. So this will be 2k times 2k is 4k squared. 2k times minus 4 is minus 8k, and we do that twice, so minus 16k, and then it will be plus 16, and then we've got minus 20 times 2k, so minus 40k, and minus 20 times 8 is minus 160 is greater than 0. Simplify this, we've got 4k squared minus 56k minus 144 is greater than 0. We could do it like this, but actually you can simply just divide by 4 everything. So k squared minus 14k minus 36 is greater than 0. So we have a quadratic inequality. Now the way we're going to do that is think about the critical values, so when it would be equal to 0, and we could use a quadratic equation for that to find them. So the critical values when you do that are, using the quadratic equation, is come out to 7 minus square root of 85 and 7 plus the square root of 85. Now if you imagine plotting the graph on the y-axis of k squared minus 14k minus 36, and then the x-axis will be k, what you would find is that there are two roots, one at 7 minus root 85, which will be a slightly negative root, which will be that one there, and one which 7 plus root 85, which will be a positive root. We also know that this is a positive quadratic, so it has a U shape, or that kind of parabola. So what we're looking for is when the y value is greater than 0. So this part of the curve here, and this part of the curve here, so it's the outside region, right, of curve. And so that tells us that k has to be either less than 7 minus the square root of 85, or k has to be greater than 7 plus the square root of 85. And that completes question 10.